Assalamualaikum and selamat sejahtera semua. So today we'll continue with elementary I/O. So in this elementary I/O, you will learn about all the input output that you are going to use in your microprocessor or in your assignment or anything that related to I/O, input and output. So let's look at the elementary I/O, the introduction of the elementary I/O. So elementary I/O actually is a two-state peripheral devices which allowing two-state condition. So since it is a two-state condition means that it have two condition, either it is 1 or 0, right? So it's a two-state, either it's 1 or 0, ataupun it is either on or off condition. Okay, that is a two-state peripheral devices. So example of the elementary I/O such as bulb, okay, in which you can see the bulb can either turn on and lights off, okay, or you can have a switch, you can turn on the switch, turn off the switch. You have a LED, either your LED can light up or light off. And then what else do you have? You have 7 segment display, either you want to display a certain number to that 7 segment, or you want to off that 7 segment. That is a two-state peripheral devices, right? So in AVR, it can involve more than one bit at a time, such as a BCD. Okay, since BCD is a 8-bit device, okay, so but it is still a two-state peripherals. So what is the requirements? Okay, so the requirement in elementary I/O is where bit signal can be written to output device under a program control, and the bit signal can be read from input device under a program control. So the requirement for elementary I/O either is can be read or write. So device required in order to use the elementary I/O such as latches. Okay, so these latches here used for the output, or tri-state buffer used as a input, right? So example of output device such as LED, bulb, relay coils, 7-segment display. While for example of input devices such as push button, proximity switch, rotary BCD decoder, or you have a transducer, or you have a sensors, and etc. Okay, let's look at the first elementary I/O, which is LEDs. So this is the common elementary I/O that you use in your lab. Okay, since you are the electrical engineer, so you will use these LEDs in any of your projects. So this LED is a semiconductor device that convert electrical energy directly into the discrete color of light. Okay, means that this LED will convert electrical energy to a color of light. So this LED has two terminals that you need to know in order to use these LEDs here. Okay, in which this terminal here you must be connected correctly. If you wrongly connected this terminal, what happen is either your LED will damage and your LED will not work properly. Okay, so there are two terminals, which is a anode, a positive terminal, while cathode for the negative terminal. So how you want to identify between anode and cathode in your LED? Okay, so this is your LED. This is your bentuk LED. Okay, so this is the flag. Okay, then you have to see you have a flag, and then one LED legs have a longer leg, the other one has shorter leg. Alright, so long leg and a shorter end inside the leg stand for the anode terminal. Okay, you have see. Okay, this is a long leg and the shorter end inside this leg. So you know that this is a anode. Why? For the short lead and has larger end inside the LED sometimes slide flat on the birth of one of LED. So this one here, to identify whether this your LED uh, either is a cathode or not, you can see either of this lid here, okay, or pins here, okay, legs. Sometimes we call it kaki, okay. Okay, you see this one here for cathode, it have a shorter lid, and you see here it have a big end inside of this LED. Okay, so this is the symbol of the LEDs. Okay, you see here, this is a symbol, and then you have an arrow here, so you know that this is a positive terminal and this is the negative terminal of your LED. So LED is easily damaged by heat, alright, and it has variety color depending by the semiconductor material used. You have a red LED, yellow LED, blue LED, red LED, white LED, etc. There are a lot of color for LED. Sometimes you can see the RGB LED, but this one got 3 legs. Okay, it has a 3 legs, positive, negative, and the other one is for the color selection. Alright, so you are okay. Bear in mind that you are never connect LED directly to a battery or power supply. Why? Why you cannot connect your LED directly to your power supply? Because it will damage your LED. Okay, so in order to avoid that, you need to have a resistor and connect it series to your LED so that it can limit the current, okay, that goes through to your LED. Okay, so it will make your LED more safe and it will not damage your LED. So this is how you want to connect your LED to resistor, right? So usually we use the 1 kilo ohm resistor. Okay, it's suitable for most LED if you supply voltage 20 volt or less. Sometimes we can use a 330 ohm also can. Okay, so this is your VCC. Okay, make sure that the positive and negative terminal here is properly connected. Okay, positive terminal connected to VCC, negative terminal goes to ground, and you see here, okay, you have a resistor here, so this will limit the current that go to your LED, and see from VCC to ground, so the current will flow from here to here, because this is on 1 and this is 0, so current will flow from high to low. Okay, if you put the LED wrongly, which is this negative terminal, and while this one is negative positive, then what happens is the current cannot flow to your LED. Okay, so this one here you already know how to calculate it. Okay, so you already know, right? V equal to IR. You can use this formula here. Okay, so you can get your what is your resistance. So this one you already learned in circuit theory. So I will skip this part here. So how to turn on LED that are connected to your micro:bit? Okay, so since this one here, okay, this is your micro:bit. Okay, they are connected to micro:bit. Okay, so 5 volt. Okay, since this is your LED, okay, this is the symbol of your LEDs. Okay, you know that this one is positive terminal and this negative terminal, and then you have a resistor to limit the current that flow to your LED. So since this is 5 volt, okay, so this 5 volts, usually in digital we take it as a logic 1, okay, and then go to LED current. While you see here, this at our output pin of your micro:bit, you give a 1 as well. What happens is 1 1, so no current flow to this LED. Okay, so what happens is the LED will off. Okay, and while if you connect your LED something like this, okay, positive, negative, okay, so this is, since the positive terminal connected to 5 volt, so this one is logic 1, and this one here, you see you give a 0 here, So what happen is your LED, the current can flow from high to low. So what happen is the LED will turn on. Okay, so this is how you want to estimate the resistor value. Okay, so R equal to voltage divided by current. Okay, so you calculate based on this one here. 5 minus with 1.8 minus with 0.4, then you get the current here. What is the current value? And you get your resistor. Okay, so this is how you're going to connect your LED to your micro P. Okay, so for example if you're going to use the port B are connected to LED. Okay, so this is the LED. The positive LED goes to your positive 5 volt, while the negative go to your pin out of your port B. Okay, and then you need to put a resistor lah. Okay, make sure that you put a resistor. Okay, to avoid, okay, to limit the current that flow to your LED and to avoid your LED from getting damaged. Okay, so since this you connected this LED here, the positive LED to positive 5 volt here, what happen is every time you want to turn on your LEDs, so you need to put 0. Okay, you need to give 0 to your port B. Okay, if you give 1, what happen? If you give, in this case here, if you give 1, LED will off. Okay, if you give 0, LED will turn on. Okay, so the reset, you go to the reset button, and then all the VCC are go to the 5 volt, and all the ground here must connected to ground, so that your micro P will work correctly. Alright, then this is another okay circuit diagram how to connect your LED to your micro P. So this one here we use the port A. Okay, this LED here connected to port A. Okay, you see here all the positive terminal are connected to your VCC, and the negative terminal of LED connected to your port A. So this is a port A. Okay, again, in order to light on this LED, what happen is you need to give 0 at the output of your LED, of your port A actually. Okay, so the current will flow from high to low, and the LED will light on. So now we are going to write a program. Okay, how to count up and show the result of the counting by displaying at 8 LED that are connected to port A. Okay, first, what you're going to do? Okay, so you draw your micro P. Okay, all of the port A here are connected to your LED. Okay. Okay, make sure that the terminal is correct. If you, okay, so this is positive and this is negative, so all the negative here connected to ground. Okay, actually your LED have two common. Okay, the first one we call it as a common anode, the other one called a common cathode. Okay, you need to differentiate what is a common anode and what is common cathode. The common anode is where your LED, all the anode, the positive terminal are connected to your VCC, while for the common cathode, all the cathode terminal or the negative terminal here are connected to your ground. Okay, so that one is a common cathode and the other one is common anode. Alright, so in this program here, you are going to write a program to count out and show the result of counting by displaying at LEDs that are connected to port A. Okay, so how are you going to do that? So this is port A. Okay, so this one here, this is how to write in assembly language. First, you need to include ft2def.isc because you're going to use the input output port. And then you see here, okay, what this 4 instruction do? Okay, this 4 instruction used to initialize your step pointer. Why you need to initialize your step pointer? See here, you are going to use a subroutine. So in order to use a subroutine, you need to initialize your step pointer. That's why at the top of this program here, we initialize our step pointer so that our step pointer will point to your remain. Okay, and then this one here, okay, LDI R2008FF out DDRA R20. What is this? What these two lines do? These two instructions do? Okay, because your LED are connected to your port A. Okay, so your port A should be at output port. So you need to initialize so that your port A become output port. How to initialize your port become output port? So you need to initialize at DDRA, in which you need to send 1 so that it become output. If you send 0, what happens? It become input. So that's why we initialize port A to initialize port as an output. We put FF to your DDRA, and then this is a load IR20 means that you want to start counting. Okay, see that the count out means that you want to start count from 0 to FF. Okay, actually here, okay, my LED here is, I use the wrong common LEDs here. I should use the common NAT instead of common cathode. Why? Because for the 0, okay, you see here, this is the number 0 here. The value that I send out to my port A is 0, 0, 0, 0, means that all the LED will turn off. Okay, if I use the common cathode, what happens is all the LED will lights up because I put 0. Okay, sorry, correct. All right, okay, so this one here, I can use the common cathode instead of common NAT. So this port A. Okay, all the port A here are connected. Okay, you have a 8-bit LEDs lah. All the LED are connected to ground. Okay, what happened here? When I give a 0 here, since this is ground, 0, 0 will 0. Is it the current flow from here to here? No. So the LED will turn off. What happened when I put 1? When I put 1, this is a high, this is a low. So the current can flow from high to low. So the LED will light up. So in this case, I need to use the common cathode. I cannot use a common NAT. Okay, what happens when I use the common NAT? When I put a 0, 0, 0, 0, what happens here? All the LED will turn on, which is wrong lah. Okay, by right, when I count from 0, okay, when my counter starting from 0, what happens is all the LEDs should be turned off. Okay, so this is my loop. Increment R20 output AR20. So what happened here? Okay, so supposedly this one need to put here lah. Okay, because our first value is 0. Okay, so we need to send a 0 to here first, to port A, and then we increment R20. Okay, so 0 will be sent to port A. So this one here, all the LED will turn off, and then we increment R20. So now R20 become 0, 0, 0, 0, 0, 1. Call a delay 1 second. So this is the delay subroutine to generate 1 second. And then R jump loop. Okay, what happens is then we send back that value 0, 0, 0, 0, 0, 1 to LED. So only one LED will turn on. Okay, which is LED bit 0, and then increment R20. So now R20 become 10. Okay, 0, 0, 0, 1, 0. So to indicate number 2. Okay, and it will repeating until your FF What happens when FF? All the LED will light up. So this is what we when you write in assembly language. But now we are trying to write in C programming. Instead of using the assembly language, we're going to write in C programming. So how to do that? Okay, to do that, okay, as I mentioned previously, the first thing that you need to do is you need to include this avr/io.h. Okay, so this is your avr header file. Okay, you need to include this file. Okay, define f_cpu f_cpu 1,000,000. Okay, what is this actually? You want to define your CPU so that your CPU has a 1 megahertz of speed, and then include util_delay.hash. Okay, what is this actually? Okay, you want to use the delay function. Okay, in which you want to create a delay, you use a delay function. Okay, so this is the delay function that you're going to use. _delay_ms 1000 means that you want to generate a 1 millisecond delay. Okay, next, int main void. Okay, so you write down all the main programming here. Okay, next, you see here the first line here. You need to initialize your step pointer, correct? But in C programming, we no need to initialize our step pointer, even though we use the delay function or delay subroutine. Okay, in C programming, you will never initialize your step pointer. Okay, because it will automatically done by C compiler. Okay, that is the advantage of using a C compared to assembly language. Why? Because in assembly language, you need to initialize your step pointer so that your step pointer point to your running. Okay, next, what happened here? Okay, you need to initialize your port A as a output port, similar to this one. Okay, initialize your port A as output port, so DDRA equal to OX FF, and then unsigned char counter means that you saying that your counter here, okay, label counter here is a unsigned character. Okay, unsigned number. Okay, why unsigned number? Because you're going to count from 00 to 255. So this is a positive number. Okay, and then you set your counter equal to 0. Okay, while 1, why is while 1? Similar to this one. If you see here, R jump loop. Okay, so this loop here will do continuously. Okay, so we use the while 1, open curly bracket, close curly bracket, and then port A equal to counter. Okay, so you send your any value from counter to your port A, so that it will display to your LED that are connected to your port A, and then counter equal to counter plus 1, which is similar with increment R20 in this assembly language. Alright, and then you call your delay. Okay, _delay_ms 1000 means that you want to generate 1 millisecond delay. Alright, and it will keep repeating. Next, we are going to look at the 7-segment delay. Alright, so the 7-segment delay used to display a decimal digit, okay, to your output. Okay, so in order to do that, you use the 7-segment LED display. Okay, in which this 7-segment can use to display a decimal number. Okay, the display could represent, i.e., the number of the times as a switch was pressed. Ataupun you can use this display to count a certain event, for example. Right? So the digit 0 to 9 and hexa A to F can be displayed by giving the proper 7-segment code. So this is the code that I need to use in order to represent your numbers here. So this is the numbers. Okay, so this column here, right, so this is your numbers. This is your codes that you need to send out in order to represent the numbers. Okay, so for example here, okay, so you see here, so since your 7 segment display has 8 LEDs starting from A, so this is a A, B, C, D, E, F, G, and the other one is your decimal point, H. Okay, if you want to display number 0, what happen is the A, B, C, D, E, F should lights up, while G and H should be turned off. Okay, so what is the proper code that you need to send out to your 7 segment display? So again, okay, in this 7 segment display, you have two types of 7 segment display. One is common AND, the other one is common catet. Okay, what is a common AND? Means that all the AND, the positive terminal connected to your positive. So how to turn on your LED? By giving 0, while common catet, all the catet, which is all the negative terminal, are connected to your ground. So how to turn on your LED? By sending 1. Okay, so in this code here, okay, you see A, B, C, D, E, F. Okay, A, B, C. Okay, so this is A, B, C, D, E, F are given 1, means that you use a common catet, while G here is get 0 because you want to turn off this G. Only A, B, C, D, E, F are turned on. Okay, to display a 0. What about 1? Okay, 1, which LED that should be turned on? Okay, for 1, okay, the LED that should be turned on is B and C only, because you want to represent number 1. Okay, so by looking at this code here, so A 0, B and C got 1, while the rest you put 0. Okay, so let's see another example. Okay, now you want to display 7. Okay, which LED that you need to turn off? Okay, 7. So this is your 7. Okay, the LED that you need to turn on is A, B, and C. What about the rest? Give 0. Okay, you see here, A, B, C get 1, the rest you get 0. Alright. So as I mentioned earlier, okay, your 7 segment display have two common types. The first one is a common AND, the other one is common catet. What is a common AND? Okay, all the positive terminal of your LEDs are connected to VCC. So in order to turn on your LED, you need to give 0. Okay, you see here. So this is a common catet. Oh, sorry, this is your common AND. Okay, you see all the positive terminal of your LED. This positive terminal, positive, 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 positive terminal here are this positive, another positive are connected to VCC. Okay, so that's what we call it as a common AND. What about the common catet? Okay, you see here all the negative terminal, okay, negative, negative, negative are connected to ground. So this is another negative, 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 all connected to your ground. Also as your DP. Okay, your decimal point. This one. Okay, this is your DP. Your H. Sometimes we use a DP, sometimes we use a H. How to turn on this common catet? By giving output high. So this low. So this one you need to send 0 to your common AND to make it turn on. If you put 1, what happen? It will turn off. What about for common catet? You need to put 1 to on, while 0 to turn off. Okay, so this is your common catet, and this is your common AND. configuration. Okay, you see all the negative terminal are connected to your ground. So we call it as a communicated. So how to turn on? So you need to put one lah kat sini. You need to put one so that it will turn on. Why? Because the ground is actually a zero. Okay, the current only flow from high to low. If you put zero here, what happens? Zero. This one is zero, so no current flow through your LED. While for the common net, you see here all the positive terminal of your LED are connected to your VCC. Okay, while this one here will go to your port. How to turn on? You need to put zero lah. Why? Because VCC actually a logic one. Okay, so the current will go from high to low. What happens if you put one? The LED, since this is one, so no current flow through your LED. Okay, so this is how you're going to attach your 7 segment to your what we call AVR to your microP. Okay, so this is your 7 segment. You see here, you have the negative. So what is common configuration that you use here? This is common cathode. Why? Because all the cathode here are connected to LED. Okay, so this one here go to your blah 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 to your port B, and then if 0B, okay, so if this value are coming from your port B, you see here, okay, 0 0 1 1 1 1 1 1 go to your port B. What value that will be displayed on your 7 segment display? Okay, since this is a common cathode, when you put one, what happens? LED will turn on. If you give a 0, LED will turn off. Okay, so since this is PB0 connected to A, PB1 connected to B, while PB7, the decimal point here are connected to your decimal. Alright, so you can know that. So this is okay, so this is 1, so A will turn on, B also turn on. Why? Because B also got 1, C1, D1, E1, F also 1. Okay, 1 1 1 1 1 1, while G and decimal point are turned off. Okay, why? Because you give 0. Okay, so what number that will display in this 7 segment? Okay, you want to display number 0. Okay, let's look at the example. Okay, a 7 segment display is connected to port C. Okay, you are required to write a code that display number 1 to your 7 segment. Okay, let's this one here. Okay, this 7 segment display is a common cathode. Okay, so this 7 segment display are connected to port C. Okay, how to write a code so that the number 1 will be displayed to your 7 segment. Okay, first thing first, what you're going to do, include this header. Okay, include avr/io.h. Okay, and then integrate int main void and do your programming. Okay, start your programming. Okay, since 7 segment connected to port C, what happened to your port C? So port C automatically become output port. So how to initialize output port to port C? So you need to initialize by using a DDRC, in which you need to give 1 so that it become output. If you give 0, it will become input. As simple as that. Okay, initialize. Okay, first thing first, if you see any question that something like this, they are they are using an input and output port. So first thing first, what you're going to do is to initialize your input output by using the DDR. Okay, so that's why DDRC equal to OX FS. So automatically your port C become as output port. And then now you are going to send number 1, or you are going to display 1 to to your 7 segment. Okay, so you need to know lah what code that I'm going to send out to your port C. Okay, so as we know that this is our 7 segment display. Okay, so this is A, B, C, D, E, F, G, and H. Okay, usually in 7 segment display, A always go to your LSB, least significant bit. H always go to your MSB. So this is how you're going to C, D, E, F, G, and H. So don't write A, B, C, D, E, F, G, and H, which is wrong. Okay, always write A as a least significant bit, while H, or the decimal point here, as a most significant bit. Okay, now you're going to display number 1. Okay, so this is number 1. So number 1, which LED should be turned on? So LED B and C lah, while the rest of LED here should be turned off. Okay, because we want to display number 1. Okay, what are the code that you need to send out to your 7 segment display? Okay, so since this one here, okay, before we proceed with the codes, okay, you need to know that what type of common configuration that you use in your 7 segment. So in this case here, you use a common cathode. Okay, so since this is a common cathode, means that you send one, the LED will turn on. Okay, so what happened here? So B and C will get 1, while the rest will get 0. Okay, so that's why here you see a port C equal to OX 0, 6. Okay, so because, okay, if you divided this one here to hexa, so this is a 0, so this is a 6. Okay, let's say lah, what happened if I going to use the common NN? Okay, so what value that I need to put here to send out to my port C, so that my 7 segment will display number 1. So since a common NN, okay, to turn on your LED, you need to give 0. Okay, so which LED should I turn on? C and B. So I need to put 0 at C and B. What about the rest? I need to turn off lah the LED by sending 1. Okay, so what value that I need to put here? So this one is F. What about this one here? 8 tambah 1, which is a 9. So okay, I need to write port C equal to OX F9. Okay, if I'm using a common NN configuration. If I using a common cathode, yes, I can set this number here, 0, 6. Okay, so make sure that the common configuration are correct, because sometimes, okay, you are forgetting the common configuration that are used here, so your answer here will be wrong. The code that you send it out will be wrong if you use the wrong common configuration. Okay, let's do another example. Okay, similar to this one here. Okay, a 7 segment is connected to port A. Write a code that display 3 on the 7 segment. Okay, for this one, okay, let's lah this common configuration here use a common, and then all the N are connected to VCC. Okay, what number that you need to send out in order to display this number 3? Okay, first, how you going to do? Okay, include the header file. Started with your integer main void, right? And then what happened here? Okay, port A or port C? Okay, in this case we use a port A lah. Okay, so port A connected to your 7 segment. Okay, I know that port A is somewhere around here. Okay, never mind, we just use this is a port A. Okay, we don't want to have a similar example as the previous slide. Okay, so we just change the one. This is a port A. So what are we going to do? Okay, since this one here, all right, this one here connected to your port A, 7 segment connected to port A, so automatically you know that your port A need to be as a output port. Okay, how to make your port A as output port? How to initialize your port A so that your port A become output port? So you need to initialize at DDRA by sending what value here? 1. Okay, so that it become output. Okay, how to do that? DDRA equal to OX FF. Okay, now after you initialize this port A as output, then you can send out the value that will display this number 3 to your 7 segment. Okay, again, you need to remember your, okay, you need to identify what code are you going to send to your port A. Okay, so this is A, B, this is your 7 segment, C, D, E, F, G, and decimal is your H. Okay, so now you're going to send to display number 3. So number 3, A should be turned on, B on, C also on, D on, G on. What about E and F? E and F should be turned off. Alright, so this one here, you should turn off this one. Right, so what are the code that I need to send out here? Okay, so before I write down my codes, okay, so I need to put, okay, so this is my A, B, C, D, followed by E, F, G, and H. Alright, so now I need to see here what type of common combination that I use in to my what we call here 7 segment. Okay, see this one here is a all the connected to VCC, so I know there's a common ended. So common ended, what happen is I need to give 0 in order to turn on the LED. Okay, so in this case here, okay, A, B, C, D, and G should have 0. A, B, C, D, and G should have 0. What about F? So this one got 1. Okay, so I just write down, okay, I just replace this one here with port A equal to 0 B 1 0 1 1 0 0 0 0, ataupun I can write down or port A equal to 0 B, no, not 0 B. Okay, I want to send out in hexadecimal. Alright, 0x, what number that I need to put here? Okay, so this is 8, 4, 2, 1, so 8 plus 2 plus 1 is 11, so AB, B, 0. So, okay, so this one I need to replace here lah. Why? Because this value is wrong lah. If I use this common catered, yes, this value is correct. But now I using a common ended. Okay, so this value is wrong. Okay, what happens if I give this value here to my common ended? Okay, which LED will turn on? Okay, so in this case here, if I give this value 0B01000111 to my common ended, okay, so I will get a alien character. Okay, and this, okay, if you see here, alright, this is A, B, C, D, okay, E, F, G, and H. Okay, hash F, E will turn on. Okay, F, E, while the rest will turn off. So this is a alien character that I send out to my port A. If I use this value, so make sure that you need to identify what common configuration that your 7 segment use. Then after you identify that you can get the codes. Okay. Right, another example. Okay, a switch is connected to pin B0 and LED to PB7. Write a program to get the status of the switch and display it at the LED. Alright, so this switch, okay, you see this is a switch. Okay, so this switch here is active high switch. Okay, this is a active low switch. Okay, sorry. Okay, so in this case here, you have a switch connected to your PB0 and LEDs are connected to PB7. Okay, before we start with what we call our programming, so we need to identify what type of switch that we use here and what type of LED configuration LED that we use here. Okay, let's look at the LED first. Okay, so this is positive. Sorry. Okay, pen. So this is positive. This is negative. Negative LED are connected to ground. So I know that this is a communicator. When I use a communicator, what happens is when I give 1, the LED will on. When I give 0, the LED will off. Okay, next. This switcher. Okay, so you see VCC perintah go to your PB0 and then you have switch connected to ground. So what type of switch that I use here? Okay, switch, you have two type of switch. One active high and the other one is active low switch. Okay, in this case here I use a active low switch. Why active low switch? Because every time I press this switch here, okay, value 0 will go to my copy. Okay, 0 will go to my copy. So this is a active low switch. What about active high switch? Okay, for the active high switch, so this is your active high switch. Okay, you have a switch. Sorry. Alright. So this go to your PB0 and this is your LED. Is it correct? No. I'm sorry. Wrong. Okay, the what we call here the perintah here should. Okay, I need to put my perintah at my. So this is my ground, and I have a perintah here. So at my VCC doesn't have any perintah. Okay, if I don't put perintah here, what happens? It will be short circuits, right? So I need to put perintah at my ground. Okay, so this okay, and then this is my switch. Okay, so this is VCC. Why? When I press this switch here, okay, value 1 will go to my copy. Alright, so this is a active high switch. Okay, you need to identify which switch that you're going to use. Is it active high or active low switch? Okay, when I release my switch here for active low, what happen is value 1 will go to my copy, and for the active low, when I release my switch, what happen is the value 0 will go to my copy. Okay, so now we already identified what type of switch that we use here. Okay, so this is active low, right? And then you see here, whenever you press the switch, the LED will turn off. Okay, how to write the program here? Okay, first thing first, what are you going to do? Okay, after you see this circuit here, what are you going to do? You need to initialize. input output port. Okay, you need to select your DDR X. You have two DDR here that you use. Oh no, only one DDR here that you're going to use. One is that is DDR B. Why? Because this, you see here, this is PB0 and this is a PB7. Okay, so this is how you're going to write in assembly language. So I just skip this one here. Okay, I want to focus on the C programming. Alright, so include this file, check int main void, my main program, open curly bracket and close curly bracket. And then now here, you see here. Okay, so now you see PB0 go to my switch, so this is become input. PB7 go to my LED, so this one get output. So how to initialize that? So you see here. Okay, bit 0, I give 0, while the rest of the bit I initialize as 1. So all the bit from PB7 to PB2, PB1 here. Okay, this PB7 to PB1. Okay, I initialize it as a output port, while only PB0 I initialize it as a input port. Okay, next. So remember, recall back, every time you initialize your port as an input port, you need to enable your pull up resistor. So how to do that? So to do that, I can simply write down something like this. Ataupun nak senang, the easy way to do okay, this one also same as above. Okay, you can use either this one. Okay, this is the first one or the second one. Okay, means that you initialize PB0 as an input and the rest as a output. Right. So after that, I need to, because this one here, if you see this one here, this is an input, so I need to enable my pull up resistor. How to do that? Write down port B sama dengan 0B. Okay, since PB7 anti PB1 is my output, so I just put 0, 0, 0, 0, 0, 0, 0. Only PB0 I give 1. So this one here, enable pull up at PB0 only. Okay, and I use the Y11 because we want to monitor this switch continuously. Okay, so Y1 open curly bracket, close curly bracket. Okay, next we need to check our switch. Okay, if pin B equal 0B 1111110, because this is active low, see, this is active low. Okay, what happened when this one got 0? Alright, so PB7 will turn off. Okay, so I just put port B sama dengan kosong. Okay, to turn off my PB7. Or I can simply write port B equal to 0B1. The rest I put zeros. Sorry, 0, 0, 0, 0, 0, 0, 0, 1. Okay, why 1? Because this one here, I don't want my pull up enable at port B0 disable. Okay, pull up resistor at port B0 disable. So that's why I put 1 at my PB0. Else, what happen else? Okay, if not press, okay, what happen is port B equal to this value. Okay, maybe we can put 1 at the back. Okay, so this is where you connect to your LED, and this is where you connect to your switch to enable your pull up resistor. Okay, next we have another example here. Right. Okay, actually we have a lot of examples. So, alright, so now you are going to using the 77 display, write a program to display number 0 to 9 continuously. How to do that? Okay, so this is how you're going to write in assembly language. Now we want to focus how to write in C programming. Okay, so first, what I'm going to do, I include this file. Okay, so where are we? So now I include this header first. Alright, so after I include the AVI, so then I initialize my sorry, then I initialize my CPU, so that my CPU have 1 megahertz in speed. And then next I want to use the delay function to generate a delay. Okay, because I want to display this value 0 to 9 to my 77 display, so I need to what we call to put a delay lah, so that you can see the change from 0 to 1 to 2 to 3 to your 77. Alright, so in this case here, okay, my DDRB are my 77 are connected to port B, so I need to initialize my port B as a output port. And then while one, okay, so means that it will continuously display this number here to 77 display. Okay, by looking at this, okay, the 77 display here are connected to using a common gated configuration. Okay, so this is how you're going to display 0. It is 1, 2, 3, 4, 5, 6, 7, 8, and this one is 9. Just use simple programming. Okay, don't use the array, the table, or etc. because that one is more complex. Just use the simple programming. Okay. So port B, send this value here to display 0, call a delay, 2 millisecond delay. Port B, send this code here to my port 77. So my 77 will display 1. Again, so this is the value to display number 2, 3, 4, etc. And we will keep repeating. Just like that. Okay, next, we have, okay, you are going to write a VLC program to get a byte of data from port C and then send it to port, get a byte of data from port B and send it to port C. So in this case here, because you're getting a data from port B, so port B become input and port C you need to initialize as a output because you're going to send the data. Okay, so you draw your circuits. Okay, so this is your port B and this is your port C. So this is your input and this is your output. Okay, that's okay. This one means that it's an 8-bit. All the 8-bit of port B become output. So this one also all the 8-bit become input. So how to write a program? Okay, so include AVR io.h and then integer main void and then unsigned char temp. Okay, so I use a variable temp as an unsigned number and then okay, this one initialize your port B and port C so that your port C become input and output. How to initialize? Again, using the DDRX. Send 1, it become output. Send 0, it become input. Okay, while 1, what is while 1? Okay, because you want to do continuously. So any input there you're going to put to your port C will be displayed to your output at your port B. So that's why temp equal to pin B, port C equal to temp. Okay, first you read the data from pin B, go to your temp, and then you display that value. Okay, so port C sama dengan 10 means that you display that value that you read from pin B, display it to your port C, just like that. Okay, don't use port C equal to pin B. Okay, so this is wrong. Okay, you need to get this value here to your any variable, and then from that you can go to send out to your port C. Don't simply write port C equal to pin B. Okay, so you can put a return 0 here, or you cannot. You also or you also okay, if you want to discard the return 0 also can. Okay, another example. We have a lot of example in this I/O programming. Okay, so you are going to write a C program to monitor bit 7 of port B. Okay, so this is your always draw your circuit. Okay, so this PB7 monitor, so means that there is an input or switch. Okay, and if it's one, make it bit for port B as an input, as change pin for port B as a output. Okay, so PB4. Okay, and then this one it become input or okay. How to do that? Okay, so your monitor, if one PB4 sama dengan input, kalau kosong PB4 you make it as a output port. Okay, how to do that? Okay, again, include this file integer main void, and then next, okay, initialize your PB7 as a input port. How to do that? Okay, so you can simply ddrb equal to ddrb and with okay tilde, okay, 1 shift to the left by 7 times. Okay, why I use this ddrb n? Because I don't want to change any bit in my DDRB. Only bit number 7 will get 0. The rest will follow the previous value. If the previous value is 0, and it will follow the previous value. Okay, let's say something like this. Okay, my current DDRB now is contoh lah ya. Okay, let's say my current DDRB something like this. Okay, so 1 1 1 1 0 0 0 0. Okay, this is my current 0 1. This is my current DDRB. So what happen when I write down something like this? Okay, dia akan jadi okay, so end with okay, first 1. Okay, you have a 1. This is value 1 in binary. Okay, you want to shift it to the left by how many times? 7 times. So 1 2 3 4 5 6 and 7. So dia akan jadi, it will become 1 0 0 0 0 0 0 0. So okay, this is what happened. And then you got a tilde here. So what happened when you got a tilde? Okay, and then from this number you have a tilde. What happened is kamu akan invert. So tilde stand for inverter. Okay, so this is the value. Okay, now this value here you're going to end with your DDRB. Okay, by right you want to change only bit 7 jadi kosong, while the rest the value are remain. So how to do that? So 0 1 1 1 1 1 1 1. You do a logical AND, so you get this is 0 0 0 0 1 1 1, and this is 0. See, only bit 7 change from 1 to 0, while the rest of the bits are remains. Okay, that's why we use the DDRB and with what value that you're going to change. Okay, so only bit 7. So in this case here, only bit 7 you initialize as a input bit, while the rest depends on the previous value. Okay, while 1, open curly bracket, close curly bracket. Okay, so because this one here you are going to check whether you press on, not press your switch. Okay, so you can use the if else statement. If pin B, okay, if pin B equal to this value here, okay, so if pin B end with this value here, ataupun you can write down if pin B equal to 0B 1 0 0 0 0 0 0 0, because we want only check bit 7, the rest you don't want to check. Okay, doesn't matter if you and then do press on, ataupun or you can put pin B equal to pin B and with 0B 1 0 0 0 0 0 0 0 also can. If pin B equal to this value here, what happen is, okay, you know that you press this bit and then you're going to make your PB4 as a input. So that's why DDRB equal to DDRB and with tilde, okay, shift 1 to the left by 4 times, which is similar to this one. Okay, so automatically you make a bit 4 of port B as an input. Else, what happen else? DDRB equal to DDRB or with this value. Okay, let's say lah, this is the current value of your DDRB. Okay, I want you to see this one because this one we already did here. Okay, so why this one we use a this vertical pole here rather than end symbol? Why we use the logical OR? Okay, because this melibatkan, this involve the value 1. Okay, this involve of value 0. That's why we use the and rather than this one. Alright, so now, okay, 1. Okay, this is your number 1, 0 0 0 0 0 0 0 0 1, and then you want to shift how many times? 4 times. 1 2 3 4. So end up dia akan jadi 0 0 0 1 0 0 0 0. So this is the value after you do the shifting. Okay, then you're going to or with your DDRB. What is the current value of our DDRB? So let's say this is the current value of our DDRB. So 0 1 1 0 0 1 0 0 1. Okay, so now we are only want to change this bit while the other bits will remain. So you see here, you do a logical OR, so dia akan jadi 1 0 0 0. 1 OR with 1 you get 1 0 1 1 1 1. So only this one is this one is 0. Change while the rest the value remains. So that's why we use the OR here. If you use the AND, what happen is, if you use the AND, all the value here will become 0 only. Okay, all this value here will become 0. Only this one will change. Alright, so that is for this example 723. And next, the last part of this, the last example here, you are going to write a AVRC program to get the status of bit 5 port B and send it to bit 7 of port C continuously. Okay, so draw your skirts. This PB5 and this is your PC7. Okay, so status, to get a status, what happen here? You connect it to switch lah. Alright, Okay, so this is your switch. Okay, and while this one here, send it to port B, so this one you can connect to your LEDs. Okay, depending on this switch here, it will light up or turn off according to your switch. If you press, it will light up. If you not press, it will turn off. So how to do that? Okay, so this one here, again, include this file. Started with integer main void, open curly bracket, close curly bracket, and then since you have two port here, one port should be input port, so PB5 should be input port, while PC7 become output port. So in this case here, because I only have PB5 and PC7, the others I'm not going to use, so why not we just initialize all the port B as an input while all the port C as output. Easy to do that rather than only a selected bit you initialize as input output. Okay, so this one here, so why not I just write ddrb is 0, so I make all the port B as an input port. Okay, after I made all the port B as our input port, what happens is I need to initialize, I need to enable my pull up resistor, so port B sama dengan OXFF. Okay, enable pull up resistor, and then after that ddrc OXFF. So I initialize all the port C as a input port. Okay, so I replace this one. While one, open curly brackets, close curly bracket. Okay, if pin B end with 1, go to the, okay, shift to the left by 5. Okay, if pin B equal to 1, what happens is port C equal to port C or with this value here. Ataupun you can simply write down port C equal to 0B. Okay, where is my LED? So my LED are connected to port PB7, PC7. So 1 0 0 0 0 0 0 0. Something like that. Else port C sama dengan, okay, 0B 0 0 0 0 0 0 0 0. Okay, if my pin B5 is 0, then port C also get 0. If my pin B5 is 1, so my port C bit number 7 I give 1. Okay, close the bracket and then return 0.